Hello, sophomore students. This is Mr. Hartz. Sorry, I'm absent today. My stepson is graduating from high school, and he has his baccalaureate mass this morning and a brunch this afternoon. Um, so, I want to give you guys an opportunity to expand on the law of cosines that we learned about in class yesterday on Tuesday. So just to recall, there were two equations that are going to be really important for the law of cosines. It's the same equation, just solved slightly differently. Um, if we have the form SAS, just as a reminder, we want to use the equation c squared equals a squared plus b squared minus 2ab cos c. Also, just a reminder, I'm telling you this to you now. I also want you to write this in your notes. You're going to actually show me a picture of your notes to show that you did this, to make sure you've got good notes that you can use to help you solve these problems. Okay. So just a reminder on this SAS, little c is the unknown side. Little a and little b are the known sides. And capital C is the known angle. So we'll use that every time we have an SAS setup to find that third side that we don't know. If we have an SSS setup, then we want to use this same equation, but it's going to be solved for the angle. That looks like this. Again, we showed in class how it's just really the same equation as the SAS, law of cosines equation. This time, though, this is going to make it easier to solve for a missing angle, which is good because we already know all three sides. The important thing to understand here is that the angle we're solving for, in the general equation, is capital C. If you notice, the one side that's unique here out of the three sides is the c squared. It only shows up once. A and b show up twice, and it's also the one that's negative. Okay. So that little c is always the side that is opposite from the angle you're solving for. So that little c is the side that is opposite from the angle that we're solving for. A and b then are the two sides that are next to the angle that we're solving for. All right, I'm going to show you 4 examples. And in each example, I'm either solving for one thing. In the first 2 examples, I'm just going to be solving for one side or one angle. And in the third and fourth examples, I'm going to be solving for an entire triangle. We'll have to do both of these things on our homework that you're going to get handed out today. So let's look at example 1. Again, you can pause the video to sketch the picture into your notes, and then unpause it when you're ready to solve. So here's the problem. Go ahead and pause it now and draw this picture, and then unpause it, and I'll show you how to solve for x. Okay, so when I look at this problem, I see that this problem is set up in the SAS form. I know 2 sides, 13 and 14 are 2 sides that I know, and I know one angle, 36 degrees, that's in between those 2 sides. So first thing is I identify this as SAS. And that means I'm going to use the form c squared equals a squared plus b squared minus 2ab cos c. Now you may say, well, I see c's, a's, b's, but all I see here is an x. Don't worry about that. Remember what these things mean. Little c is the unknown side. So in this case, our unknown side is x. So I'll start by saying x squared equals. Little a and little b, I said, are the sides that we know. The sides that we know here are 13 and 14. It doesn't matter which one we pick for a and which one we pick for b because of the commutative property. So I'm going to let 13 be a and 14 be b. So I'll have x squared equals 13 squared plus 14 squared minus 2 times 13 times 14. Sorry, I'm not writing on an edge here. Cosine of capital C. That's the angle I know. So in this case, that's 36. So I'm going to say cosine 36. Okay. I'm actually going to write that down here so it's a little bit easier to see. X squared equals 13 squared plus 14 squared minus 2 times 13 times 14 cos 36. Now to solve for x squared here, I'm just going to type the whole right side of the equation into my calculator. And I'm just going to remind myself that that number that comes out is what x squared's value is. Okay, so to find x, I'm going to have to square root both sides. So watch how I type this in. So I've got 13 squared plus 14 squared minus 2 times 13 times 14 cos 36. When I take that all in, I get 70.517 or 518. Again, that seems like it's way too big for that third side. But just as a reminder, that answer equals x squared. Right? That 70 number, this whole thing has a value of around 70, but that number equals x squared. To find x, I then have to take a square root of that answer. So my last move, law of cosines, you always have to do one more move. My last move is to do the square root of that number. And there I get my answer of 8.397. And that seems like a much more reasonable answer. Okay. So I use the SAS form of law of cosines to solve for a missing side, my missing third side, in the SAS form. As a reminder, when we tried to use law of sines on this, it didn't work. Okay? Good. Let's look at example 2. Again, when example 2, and feel free to pause the video at any time if you need to rehear something or if it's going too fast. Just pause it. You know how to do that. Example 2. Go ahead and pause the video now to jot that down, and then we'll talk about how to solve this in a second. All right, when I look at this problem, I see this as an SSS problem. I know all three sides of the triangle are 8, 10, and 15. So when we have SSS, I use the law of cosines solved for an angle. That looks like this. Once again, our formula has A's, B's, and C's in it, but we don't see A's, B's, and C's in this problem. Okay, and that's okay. We have to understand what the meaning of that equation is. Remember, capital C is the angle that we're trying to solve for. In this case, the angle we're trying to solve for is theta because it says solve for theta. How about the little a, little b, little c? Well, those obviously mean the sides. The most important side to identify here is the side that is opposite from the angle we're solving for. So when I look at this problem, I'm solving for theta. First thing I want to do is look at, hey, what's opposite from theta? What's opposite from theta is 15. That means 15 is going to go in for that spot right there. A and B can be 8 and 10, and it doesn't matter the order of 8 and 10, right? Those A and B always represent the sides that are surrounding the angle that you're trying to solve for. So in that case, it could be 8 and 10 or 10 and 8. Doesn't matter. All right, so watch how we set this thing up. I'm going to set this up. I'm going to scroll down just a hair. So instead of saying cos C, C represents the angle I'm looking for. In that case, it's theta. So I'm going to say cosine theta equals. I'm going to start with a squared plus b squared. Again, my a and my b will be 8 and 10. Doesn't matter the order, so I'll go 8 squared plus 10 squared, just like up here in the a squared plus b squared, minus, again, this one always has to be the opposite side. So in this case, it's 15 squared over 2 times a times b. Well, again, those numbers 8 and 10 are going to show up again here. And there's my equation that's going to solve for theta. What I'm going to do now is type the right side of the equation into my calculator. And I'm going to get a weird fraction for this. And sometimes it's even a negative number. Whatever it is, I'm reminding myself that that number, that weird fraction, equals the cosine of theta. I don't want the cosine of theta. I want theta. So I'm going to have to do one final move here to get rid of that cosine. And it should remind you of SOHCAHTOA. So let's go ahead and do this. Again, I'm going to type this into my calculator. In order to do that, I want to make sure I use a fraction bar. The easiest way to get a fraction bar is hit the green alpha button. And then just to the right of it, the X button. That makes my fraction bar pop up. So now I can do 8 squared plus 10 squared minus 15 squared. Again, 15 is the side that was opposite from the angle I'm solving for, so that's why the 15 is the one that's different. Over 2 times 8 times 10. And I get this weird number of negative 61 over 160. But again, that is what cosine theta equals. Oops. That is what cosine theta equals. But I want to know theta. To get theta, I'm going to do the inverse cos of both sides. So my last answer here, to get my final answer, I have to do the inverse cosine, second cos, cos negative 1, of that answer that I got. And then I get an angle of 112.411 degrees. So that angle happens to be obtuse. There's an obtuse angle, 112.411. It should be the biggest angle in the triangle because theta was opposite from 15, which is the biggest side in the triangle. Okay. All right, for example 3. Example 3 says solve the triangle. So that means I have to find all the missing parts. That means I have to find little a, the measure of angle B, and the measure of angle C. Go ahead, pause the video here to sketch this into your notes. And we'll talk about how to solve it in a second. Okay, so the first thing we want to do, we first want to recognize, hey, this thing is set up SAS. 2 sides that I know, 7, 11, and an angle in between. So this is SAS. That tells me I want to use law of cosines to solve for an angle. So again, it's that c squared equals a squared plus b squared minus 2ab cos c. But this time I'm not solving for little c squared, I'm solving for little a squared first. So what I'm looking for here is the missing side. Anytime we start SAS, find that missing side first. So here's what I'm going to say, little a squared, that's my unknown side, equals. Now, in the formula, a squared plus b squared, right? We're obviously not going to be A and B in this problem, but those sides represent the known sides. So in this case, it'll be 7 squared plus 11 squared minus 2 times 7 times 11 times the cosine of the known angle, which is 82. So this formula will help me solve for A. I'm going to type it into my calculator, and then I'm going to remind myself to do the square root, right? What initially pops up will be A squared, but I want A. So I'll go to my calculator, and I'll do 7 squared, 7 squared plus 11 squared minus 2 times 7 times 11 cos 82. That 148 is A squared. I have to square root that. I'm going to do the square root of that number to get little a equals 12.189. 12.189. So that's this missing side right here, 12.189. But I'm not done. I still have to find angle B, and I have to find angle C. The interesting thing is now, I think the easiest way to solve for either angle B or angle C is to use the SSS law of cosines. Now, in order to do this, the only problem is I've got one ugly side. So I'm going to show you how to store that as the letter A, so we can just type in A. So go back to your calculator. Follow along with me here. I know that A is 12.189, but I don't want to use that rounded number. I want to use all the decimals I can. So if you notice on the lower left part of your keyboard, just above the on button, is stow. We can take that answer and store it as the letter A. So now anytime I want to use that whole decimal, I can just type A, and it'll be that number. It'll stay that way until I store something else as A. So watch what I'm going to do now. I'm going to use SSS to go after either angle B or angle C. It really doesn't matter which one. I'll go after angle B. So watch how I do this. If I'm solving for angle B right here, if I'm solving for angle B, the first thing I have to notice is that opposite from B is 11. So that's the one that's going to be special. So here's what I'm going to say. I'll switch colors just so this stands out. I'm going to say cos B equals 7 squared plus A squared minus 11 squared. Notice you could use that 12.189 number, but to be more accurate, I'm just going to call it A, because I already have that stored on my calculator, over 2 times 7 times A. So watch how I can do this on my calculator now. I'm going to say, I'm going to do my fraction. I've got 7 squared plus, instead of using that 12 whatever number, I'm going to use A squared minus 11 squared over 2 times 7 times A. When I do that, I get that weird number, but again, that's cosine B. To figure out what B is, I have to inverse cosine my answer, just like we did back in SOHCAHTOA days. So now I know angle B is 63.340 degrees. So I'm going to put that up here, 63.340 degrees. To get angle C is going to be even easier. I just have to remember that triangles add up to make 180. So now I'm going to do 180 minus the two angles I have. The 82 degrees from angle A that was given, and the 63.340 degrees that I just solved for in this problem. So watch how easy it is to get angle C. I'm going to do 180, take away 82, take away that angle B that I just solved for, and I'm going to get 34.660 degrees for angle C. Last example. And again, feel free to rewind this if you need to rewatch it or something didn't make sense. Last example is example 4, which also says solve the triangle. What you should notice right away, taking a look at this problem, pause the video now to sketch that into your notes. All right, to solve this problem, what we have to see is this problem is set up SSS. I know the 3 sides. I know 10, 17, and 22 are the 3 sides of the triangle. So this thing is SSS. So I'm going to be using my law of cosines, solve for an angle, which is going to say cosine A equals whatever, or cosine B equals whatever, cosine C equals whatever. I'm going to actually do this twice, and then the third time, I'm just going to use subtraction. Okay? So you can solve for any angle you want first. I'm going to solve for angle A first, because it comes first alphabetically. And again, to set up my equation, it's just really important to know these equations are all going to kind of look very similar, solving for A, B, or C. What's important is to think about what side is opposite from the angle I'm solving. If I'm solving for A, I see that 22 is opposite from there, right? So when I set this up, I'm going to say cosine A equals, I start with the 2 that are next to A, which are the 10 and the 17. So I'll say 10 squared plus 17 squared minus 22 squared over 2 times 10 times 7. I'm going to type that whole thing into my calculator, and then I'm going to do the inverse cosine of it to figure out what angle A is. So watch how I do that. You should be getting used to this by now. I'll do my fraction bar. I got 10 squared plus 17 squared minus 22 squared over 2 times 10 times 17. And again, I'm going to get that weird answer, but what I'm going to do to that weird answer is do the inverse cosine of it. And it looks like this is another obtuse angle. So angle A is 106.225 degrees. Measure of angle A is 106.225 degrees. I'm just going to do the same thing again, but for maybe I'll do angle B next. So when I solve for angle A, the opposite side was 22. But when I solve for angle B, the opposite side here is going to be 17. So when I set up my equation for cos B, it's going to look like this. Cos B equals, well, what are the numbers that are next to B? Well, this time it's 10 and 22. So it'll be 10 squared plus 22 squared minus 17 squared over the 2 that start are the 2 that are also in the denominator, 2 times 10 times 22. And again, I'll do this on my calculator. Fraction bar, 10 squared plus 22 squared minus 17 squared over 2 times 10 times 22. And again, I get this weird fraction. I'm going to inverse cosine that fraction. So I'm going to do second cos of this fraction. And that's going to give me angle B is 47.898 degrees. 47.898 degrees. Same thing for angle C if you wanted to, and use law of cosines. Or you can just remember that, hey, the 3 angles in a triangle add up to 180. So to get angle C, what I'm going to do is just do 180, take away those 2 numbers. I'll go ahead and do that now. 180, take away that 106 angle A, and I'm going to take away 47 point whatever from angle B. That leaves angle C to be 25.877 degrees. If you combine your knowledge of law of cosines with law of sines and SOHCAHTOA, you guys can solve any solvable triangle in the world. All right, that is it. You should now have your homework to work on. So go ahead and for the rest of the period, work on that homework. Thanks. Bye.